Let's see the second problem out of 50 most frequently asked data structures and algorithms problems. We will try to solve this problem also using Golang. So the second problem is like a best time to buy and sell a stock. Okay. So we'll just see what is this actually and what is this problem. So problem is that so you are given an array of prices where prices of I is the price of a given stock on the ith day. So what we want to do is we want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return zero. So this is also important for us. Okay. Now let us see the examples and try to understand. So example one is like prices 7, 1, 5, 3, 6, 4, right? So when try to start from 7 and see the minimum we can buy from second day and sell at the day at sixth, right? 6 minus 1 is 5. That's why you will get the 5 is the maximum profit for this particular input. Similarly, second problem, if you observe that this the prices keep going down, so you can't buy any day where you will get the profit. So because of that, we will return the 0 here, right? So these are the examples what mentioned there, and so we'll try to understand this with an example with what kind of solutions we can find for this and so on. Okay. So first, what we will do is we will try to see what are the inputs we have. We have input 7, 1, 7, 1, 5, 3, 6, 4, 7, 1, 5, 3, and 6, 4. So we can see that kind of solutions. One is the brute force thing, and second one is we will try to use some extra variable and we will try to manipulate it with the of n time complexity only. So brute force will be like of n square time complexity. Let us see like how we can do that. So with brute force, there are two solutions, right? Using brute force, we will try to use uh, the value at high. We'll use the two for loops basically. So we'll start from I here and we'll try to compare from I value with remaining all values. Okay. In this case, what we will do is uh, we will take the one. We'll take that, for example, maximum profit initialize with 0 because there is no transaction happen, we need to return 0. That's why we'll initialize with the 0 maximum profit. And so when I equal to 0 and j equal to 1, what happens? So this is high j and this is high. So the price at position at position this position is basically position prices at j minus prices at I. That means 1 minus 7, right? That is equal to minus 6 when I equal to 1 in this position. So minus 6 is 0 is greater than minus 6, so this will not work out. We can't take this value. Next, we'll try to move j to next position. Okay, j, that is j equal to now 2. In this case, what happened? J equal to 2 case, what is the value of 2? 5, right? 5 minus 7 at ith position is 7. That is equal to what? We will get minus 2. This is also not greater than maximum profit, whatever we got till now. That is initialized value. So now we'll move j. Oops. We'll move j to this position. That is 3. From j is 3. What is the value at 3 position? 3 3 minus 7 is that is equal to how much? It will be minus 4. So this is also not the value greater than whatever we expected. Still I is still here on, I is 0. Now let us erase this one. Now j will become this one. J at 4. J at 4, what is the value here? We have 6. Oops. Now 6 minus 7 is minus 1. Still this is also not expected maximum profit for now. This is actually 4. Now j equal to 5. J equal to 5 now at this position. So 4 minus 7 is equal to minus 3. This is also not a value for us. So we are not getting whatever at first iteration we are not able to get the value whatever we want. So maximum profit is still 0. So now I we will move to next actually, right? I will move to next position. I will be here. So now I equal to 1 and j equal to 2. So j will be here now. Oops. Here j. So now what is the position of j? J value is 5 minus what is the I value is 1. So here equally plus 4. So maximum profit value will become now 4, right? Because 0 is 4 is greater than 0. That's why. So now we'll move with next position. That is j here. Now it will become 3 minus 1 is equal to 2. 2 is less than 4. So maximum profit will be 4 only. Next we'll move with the next position is 6. 6 minus 1 equal to 5, and 5 is greater than 4, so maximum profit will change to 5 now. Okay, so now j will become j will become 4 now. 4 minus 1 is equal to 3 plus 3, and 3 is less than 5, so maximum profit will be 5 as of now. So like that key will move like will try to move like I equal to 2 and j equal to 3 onwards, like that will go, and finally we'll get the value is actually maximum 5 only. That's what actually we are getting the things. This is the solution 1, and this will be this time complexity will be O of n square. We'll talk about that while coding. And second solution is second solution we will one pass actually. We'll try to go through the uh, only one time by using some extra variable, and we'll finish it up. Okay, one pass means one pass means we'll go through all the values only once. Okay, so that is I'll just take the values again: 7, 1, 5, 3, 6, and 4. Right. So these are the values. So one pass what we will do is we will try to use the two variables extra. One is actually minimum price. Minimum price will be like a int max. We'll take that one. Okay. And maximum profit anyway we'll take it as a 0 initially. So in this case actually we'll just pass one by one. We'll take the I position. Okay. From this I position we'll compare with minimum price. Okay. What is the minimum price? Here maximum, right? So this minimum price is less than this less than this value, this price value, this position value. Yes, this because this is taken high actually. This will definitely become when I equal to when I position is here, the minimum price will be this price will be 7 now, because this is the starting point. That's it. When we move to next position, now we will see this price is minimum than this one. Yes. So what we will do, this minimum value will become now 1. I mean this minimum value. This minimum value 1, maximum price still 0. Now will move with, will I will move to here. How I will move to here. Now what we will do is we will check if this price 5 minus the minimum price whatever we have value here 1 is greater than maximum price, then maximum price will become this value. In this case actually 4, 5 minus 1 is 4, 4 is greater than 0 because current is 0. Right. So now maximum price will become 4 now in this position. Okay. Fine. So maximum price is 4 and minimum price still 1 only. We are not changing that now. So now I will move to here. Now 3, high is 3 and minimum price is 1, maximum price is 4. So now what we will do is again we will check it out. This value is 3 is greater than minimum value whatever we have. So we will come here and check it out. 3 minus 1 is 2. 2 is greater than maximum value which is 4. No. So we'll skip that. It will come here 6. Minimum value still 1. So it will come here. It will check 6 minus 1 is the 5. 5 is greater than 4. Correct. In this position this maximum profit will become 5. Okay. Okay. Now I will move here. So still minimum value is 1. Now 4 minus 1 is 3. 3 is greater than 5. No. So that's why in one pass actually we can get the maximum profit as 5. So we'll just return the maximum profit 5. That's it. So we can take second example also just to clarification. So what is second example in our case is so the second example is that input is 7 6 4 3 1, right? So in our same logic actually if you observe uh, minimum price is equal to int max actually. So int max and maximum price is equal to 0, right, initially. So now minimum price is this one and when you are here minimum price will become 7 and next iteration actually I come here and 6 is less than 7, so minimum price will become 6 and again it will come, I will come here and the minimum price is 4, so again 6 is less than 4, so minimum price will become 4 and move to this position again this minimum price will become 3 and come here minimum price will become 1. So in this case if you see, right, we are not able to find the when to sell this particular share. So we are not able to sell or buy anything we can do, so maximum profit will be no transaction happened basically, so that's why maximum profit will be 0. Okay. So now let's try to write the solution for these two problems. uh, First let's try to solve using brute force and then we'll try to uh, implement using optimizer solution as well, right? Coming to brute force, as we discussed, so initially what happened, maximum profit will be 0, right? That is what actually one statement we got. Next thing is what we will do is we'll try to start from I equal to 0 and I less than length of prices, uh, length of prices and and I plus plus, right? And in second loop what we will do is j equal to I plus 1 basically, right? I plus 1 and j is less than length of prices. and j plus plus. So it's very simple logic, as we mentioned. First we'll try to check the current profit. Basically current profit is equal to prices at j, okay, minus prices of I. So we will get the current difference, current profit actually, whatever the profit we get. This is actually current profit. CP means if current profit is greater than maximum profit, then maximum profit is equal to current profit. That's it. So if you do this, as we discussed the theoretical part, how this works. So this basically it will iterate all the elements in two times. So at the end, basically what we can do, we can just return the maximum profit. Okay, let me run this program and see. This is brute force. Okay, this is accepting the solutions and this is fine for us. Okay, similarly, what we will do is we will try to understand and implement the uh, optimized and one pass actually, one pass solution. So as I mentioned, like maximum profit is still same thing. And one more thing, what we can do is minimum price, min price, min price equal to, we'll try to initialize math dot max int 32 value, right? So these two values will be taking initially. Let us see what we can do with it. So what we spoke is we'll try to use each element. We try to take each element and current, I think price equal to range of prices. So here what we will do is, if we will just check it out, if price is price is less than minimum price, if price is less than minimum price, then min price we will initialize with this current price, right? Otherwise what we will do, else if we we discuss, right, we can see the difference between a price and minimum price. This p minus minimum price, this value should be greater than maximum profit. Oops. If this value is greater than maximum profit, then we can maximum profit equal to p minus minimum price, right? So what we're doing here is, in this case actually, if the price is minimum, keep going, like second example, it will keep minimum price on increasing, there is no transaction actually. So in case we reach the minimum price and the current price is greater than minimum price, then we'll come here, we'll check the difference and compare with the maximum price whatever we got till now. If that is greater than, then we'll try to initialize the maximum price with p minus minimum price whatever we got it. Okay, let us run this also. Mm, 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 mm. What is the problem here? Undefined minimum price we have, right? Okay, I think that's the solution actually. This is the O of n time complexity, because we are just trying to iterate with only one pass. So this solution is O of n, because one time. This is actually second. First solution is brute force, and which is n square. Okay, n square solution. That's it for today. I mean, for this particular second problem, we'll come up with next problem, next the top 50 problems